So let's take a look. We're going to evaluate this integral using Riemann sums. All right, so you might want to pause it here and just look at what we're doing. The intervals from 0 to 5, here's the function. Okay. Let's take a look at an illustration. So here's the function, okay? And Riemann sums, we're going to divide this up into rectangles. Okay, so n is the number of rectangles. So the sum of the area of the rectangles gives us an approximation of the area under the curve. All right. So it's an overestimate because we have this little corner here above the function. But as we increase n, you see that the approximation gets better. The overestimate gets smaller. And the idea here is that as n approaches infinity, the sum of the rectangles equals the area under the curve. Okay. So let's look at a specific rectangle. Okay, the width of the rectangle is here. Okay. So the length of the interval is 5 because it's 0 to 5. And if I divide by the number of rectangles, which is n, I have the width of each rectangle. The height of the rectangle is going to be the value of the function at the right edge. Okay, so it's the value of the function here at this x value. Okay, so here's the function and here's the x value. The x value is 5i over n. So this is the ith rectangle. Okay, so this is incrementing up for each rectangle. So here's I1, I2, I3, so on. And so this x changes with I. The height is given with this function. Okay. So basically what we want to do is add up the area. The area is the height times the width. Okay. And so our sum, as n approaches infinity, looks like this. Okay, so as n approaches infinity, the width gets smaller and smaller. The height still follows the function. And this will give us the exact value. Okay, so this is the height, and this is the width. I goes from 1, the first rectangle, to the nth rectangle. Now, let me just pause again. The rest of this is going to be algebra, basically, and I highly recommend that you do this on your own, on paper. It's really the way that you learn these things is to write it out. Watching it is a different story. What I would do is write it out, and each step of the way you can check your work with what I have here. All right, anyway, we work it out. So I distributed the 5 over n, making a cube here and a square here. And then we can pull out the constants. A half and a 2 is outside. I can pull out the n piece, and we boil it down to these two sums, sum of the square numbers and the sum of the integers. Okay, now these two sums, I'm not going to derive that right now. I could do that in a separate video if you want to see that. But I'm going to either assume that you know this already or that you look it up. Okay, they're pretty well-known sums. You probably should know those. Okay, so the square numbers are here. This is the sum of the square numbers up to n. Here's the sum of the integers up to n. All right, some more simplification. I'm going to multiply the brackets. Multiply this stuff out. Okay, so that's multiplying out the brackets and then shifting around these constants and then putting the n cubed in the denominator. Looks like that. Okay, now we can think about the limit. Okay, because here the n cubes are going to cancel, so we just have a 2 remaining. Here we're going to have an n power 1, here n power 2. So these limits are going to be 0, right? Because we're dividing by infinity. Over here, the n squareds cancel, so we're going to have a 1 here. And this is going to be a 0, because we're going to have an n power 1 in the denominator. So we apply the limit now. And we get that. Now it's just some arithmetic. And we get the final answer. So you can check this by doing the actual integration. You get the same answer. And as a challenge, I would try doing the left Riemann sums. It'd be a slightly different expression for the height of the rectangles. But as you work it through, you'll see you get the same answer. That would be a good exercise. Highly recommended. Okay, so Riemann sums. Hope that helped.